Hi guys, so now we have our next question here that is based on trig expressions as well. So now we have to simplify the following fully. So right, we know with this one we just go step by step. So what are we having here? We are having sine of 360 degrees plus theta. Right, what I said about this on our previous videos, you notice that we are on 360 degrees, positive 360 degrees. It means that we are on the x-axis, right? So then we add, when we now add by angle theta, remember that angle theta here represents any angle between 0 degrees and 90 degrees, any other angle. So if you add the positive x-axis, then you add by a certain angle or angle theta. Where is this going to land you? If that angle has to be between 0 and 90 degrees, this is going to land you where? On the first quadrant. So now you ask yourself, now we know that we are on the first quadrant. So how is sine? How is sine on the first quadrant? Sine is positive on the first quadrant because all of the trig ratios are positive on the first quadrant. So now this is what you're going to write now. We are going to write sine theta, then multiplied by, then we have 90 degrees plus theta. So 90 degrees plus theta, where are we? Sine of 90 degrees plus theta here. So 90 plus theta, the theta here, we know that we are on the second quadrant, right? So now how is sine on the second quadrant? Sine is positive on the second quadrant. Therefore we are going to have here, we're going to have this, open our bracket there. How is sine on the second quadrant? Sine is positive, but then because we have a 90, we have a sine here. Yes, we are going to actually use this to now refer to our co-functions. So remember, if we have sine 90 plus or sine 90 minus, even when it's cos 90 minus, cos also 90 plus, now we know that we are going to change the trig ratio because of this 90. We are going to refer to our co-functions. So now what is cos or sine of 90 plus? So this is the same as cos, right? And then we are having this theta here, then we're going to have cos theta, right? Remember, that's how we do it. Since it was sine, it's going to change to cos. If it was cos, it's going to change to sine because of the 90 there. We are going to refer to the co-function, then we multiply. And then yet again, now we have negative theta, tan of negative theta. So now if you see on the previous questions, we said that here we have tan of negative theta, tan of negative theta. We said that this negative here, it is telling us that now we are moving the clockwise direction. We are on the x-axis, we move on the clockwise direction. But then remember that theta is an angle between 0 and 90 degrees. So if you are moving clockwise, theta degrees. If theta has to be any other angle between 0 and 90 degrees, so this is going to actually land us at the fourth quadrant. So now we know that we are on the fourth quadrant. How is tan on the fourth quadrant? We know that tan is actually negative on this fourth quadrant. So we are going to have negative tan theta with this one here. So that's how we work around that one. So now we are having here cos of 90 minus 2 theta. So we are having a 90 minus. 90 minus, where are we? We are on the first quadrant, right? So now we know that since we have a 90, what's going to happen to this cos? It's now going to change into sine, right? But then we are on the first quadrant. How is cos on the first quadrant? Cos is positive on the first quadrant. So we are going to now have what? We are going to have sine, positive sine 2 theta. This is going to be multiplied by what? Multiplied by the tan here, whatever that we are going to get from tan. So we have 180, tan of 180 plus theta. So 180 plus theta, on which quadrant are we on? We are on the third quadrant. Now, how is tan on the third quadrant? Tan is positive on the third quadrant, so we are going to get positive tan theta. Then we move on to the next question here. When you have positive times a negative, you are going to get a negative. Then we have negative sine theta times cos theta times tan theta, right, all over. Then from this, remember, what are we having here? We are having a double angle, right? So for this sign, we still have positive times positive, so this leaves us with sine 2 theta multiplied by tan 2 theta. So now the whole expression is negative, right? So we have a negative here, so we have sine theta times cos theta. But then remember, when you are working with trig expressions like this, or trying to prove an identity, we should always write our trig expression, our trig identity, whatever that we'll be working with, in terms of only sine and cos, meaning that we'll have to change this tan using the identity, right? So remember that tan theta is equals to sine theta all over cos theta, right? That's what we are having there. Then all over, then we're having sine 2 theta. Sine 2 theta, we also don't want to have that one as well, remember. So this is a double angle, so this is a double angle. We find it on the formula sheet there. So this is equals to 2 sine theta times cos theta multiplied by tan theta. Tan theta, we said that we don't want to have this, so we are going to have sine theta all over cos theta, right? So from that one there, what's going to happen now? Let's have a look at this. We are going to have now cos theta that is going to divide up with cos theta. Then from that one there, we are going to be left with 1, right? So then we have sine theta times sine theta there. This is going to give us what? Positive, or this is actually going to give us what? We have a negative here. This is going to give us what? What is sine theta times sine theta? This is going to be sine squared theta all over. Then what's going to happen at the bottom part here, or on our denominator? The cos theta and the cos theta, they are going to divide each other out, giving us a 1, just like we had on the previous one there. They're going to divide each other out. Then the other thing that we are going to have here, let's have a look at this. Then what are we left with there? We are left with 2 sine theta. Then 2 sine theta times 2 times sine theta there, we are going to get what? We are going to get 2 sine squared theta. Alright, so that's what we are having there. Then the other thing that we have here, let's have a look at this. We are having sine theta here at the top, sine squared theta all over 2 sine squared theta. Remember that our expression is still negative, right? So our expression is still negative, so we still have negative here. So what's going to happen? We know that this sine squared theta is going to divide out with sine squared theta, leaving us here at the top with a 1, leaving us here with a 1. So what is negative times 1? Then this is going to give us 1 at the top. Then what is 2 times 1 there? 2 times 1 there is going to give us 2. So that's how we simplify this particular expression here. So remember, how do we go about this one? We always change these expressions here, or simplify these expressions here, according to the reduction formulas or the core functions. So that's how we work with this particular trig expression.